Hello students, welcome to our third video lecture in our Flipped Classroom series. Today we will be talking about circles and arcs as well as arc length. To start off, we're going to refresh our knowledge on some vocabulary with circles as well as learn a few new terms. To start off, we're going to talk about, first off, what a circle is. A circle is defined as the set of all points that are equidistant, the same distance away from a point in the middle that we call the center. In this circle, P is the center. We also have what is called a radius. A radius is a line from the center of the circle to any point on the outside of the circle. And since every point is equidistant from the center, every radius on a circle will be equal to each other. We also have diameters. A diameter is a line from one point on the circle to another point on the circle that cuts through the center of the circle. A diameter is twice as long as a radius. We also have what are called central angles. A central angle is formed by two radii and has the center as its vertex. In this example, angle APC is the central angle, as well as angle BPC. Some new terms to discuss are what we call arcs. And simply put, an arc is part of a circle. We have three types of arcs. We have minor arcs, major arcs, and semicircles. The most intuitive of these is a semicircle. So if we have the endpoints of a diameter, in this case, if we drew a line through TR, we would have half of a circle. That would be a semicircle. A minor arc is an arc that is smaller than a semicircle. And a minor arc is always described by its two endpoints. It always has 2 points listed. And we also have major arcs. Major arcs are bigger than a semicircle. In this case, arc STR is a major arc because it is more than a semicircle. And notice that a major arc is always noted by 3 of the points in the arc, the 2 endpoints and a point in between them. Semicircles are also described in this way. Notice that when we have arcs, the symbol for arc is a curved line over the letters. In our first example today, we're just going to practice naming arcs in our circle. It's a new vocabulary term, and so we're just going to practice labeling arcs so that we know what we're looking at when we're trying to solve our problems later. Okay? So first, we're going to start with minor arcs. Now remember, minor arcs are less than a semicircle and are described by their 2 endpoints. So our first minor arc is going to be DA. That's the part of our circle that's smaller than a semicircle. We have DA. We also have AC. We also have CE. And our last minor arc is ED. Notice how I put an arc symbol above each of these to denote that we're talking about arcs. These are not line segments. Okay, our major arcs are a little more, might be a little bit more confusing because we need 3 points on them. So let's look at the part of the circle from D to E. That's more than half a circle, but how do we decide if we're going to use A or C as our middle point? And the answer is, it doesn't really matter. You get to choose which point you want to use to describe your major arc. I'm going to use DAE to name this major arc. Notice that D and E are endpoints. A is between them. So another major arc that we have is from A to D. To name that major arc, I'm going to use ACD. A third major arc goes from C all the way around to A. So we're going to call that arc CEA. And finally, our last major arc is the arc that goes from E all the way around to C. So we're going to call that EDC. Okay. When you're writing arcs, make sure that you have your arc symbol above them. Okay. Then our last type of arc that we're looking at are semicircles. Now remember that a semicircle has to have 3 points to describe it as well. Semicircles are a little easier to identify than maybe a major arc is because its endpoints are just the endpoints of a diameter. So in this case, between E and A, there are 2 semicircles. Okay? So if we're going to consider E as our first endpoint, our first semicircle will be EDA. Always remember to have this middle point. The other semicircles that we have here in our circle is DAC and CED, right? Because each diameter breaks up the circle into 2 half circles, right? Think of it like you're cutting a pizza and you make one cut through the center, it makes 2 halves. That's kind of what a diameter does. So for every diameter you should have 2 semicircles. So now that we know how to name arcs, we are going to discuss how to measure the arcs. And the measure of the arcs has to do with the central angles that form them. So for a minor arc, the measure of the arc is directly dependent on the measure of the central angle that forms it. So in this case, since the measure of angle RST equals 60 degrees, the measure of arc RT is 60. Okay? So for every minor arc, we can look at the measure of the central angle that forms it. To find the measure of a major arc, we kind of have to think of the circle broken up into a minor arc and then a major arc And to find the measure of the major arc, you take from 360, you take away the central angle of the minor arc. So for instance, to find the measure, well, we have to put a point out here. We'll call that P. To find the measure of the major arc TPR, we have to take 360, which would be the entire circle, and we have to subtract this minor arc. So 360 minus 60 equals 300. Therefore, the measure of arc TPR is 300. Okay, let's take a look at a more complex situation when determining arc measures. So we're given here circle O with points B, C, D, and A around that are labeled on the circle. And our first question is asking, what is the measure of arc BC? If we look over here, arc BC is a minor arc, and since we have the measure of the central angle that forms it, we know that the measure of arc BC is just 57. Measure of BC equals 57. Our second question is, what is the measure of arc BD? Now, if we look at BD, that's also a minor arc, but it's kind of made up of two central angles. So what do? We add these two angles together, which gives us a larger, the angle that describes or defines arc BD. So to find the measure of arc BD, we have to add 57 plus 33, which gives us 90. And our third question is asking, what is the measure of arc AB? Over here we've got AB, which is a minor arc because it's less than a semicircle, but we don't have the measurement for the central angle AOB. How could we find that? Well, since AC is a diameter, we know that the measure of angle AOB will be 180 minus 57. So that's how we find the measure of arc AB. We're going to take 180 and subtract 57. And that gives us 123. So the measure of arc AB is 123. Well, our final arc that we're going to measure is the measure of arc ABC. And since we already talked about AC being the diameter, we know that arc ABC is going to be a semicircle. So we know that the measure of arc ABC is 180.